Hi, my name is Rahul. I'll be talking about autonomous IT today. We are Digitate. We are all about Agentic AI, AIOps. The name keeps on changing, but our objective remains the same. It is autonomous IT operations. So we have been around for 10 years. We have seen this transition from cognitive automation to AIOps to now Agentic AI. Uh, right now, we are Agentic AI platform for IT operations. Around 800 people, 250 customers globally, most of them global 2000 customers. How we are doing is publicly available on G2. You can go there and look us up. We have fantastic ROI for most of our customers. All of what we have built is our own IP. So let me just walk you through what we are doing. Autonomous enterprise evokes a lot of emotions depending upon who you are, what your experience has been. Uh, the way we look at it, it's a journey. Starts with enterprise IT operations being done manually, and this is largely the state of the art, where there are people who are having a lot of tacit knowledge with years of experience. They kind of know if something goes wrong, why this is going wrong in their sleep, and they do things manually. The challenge with that is it's not very efficient because whenever the issue happens, the right person has to be available at the right time, at the right place. And there are associated challenges. From there, some enterprise take up task automation, and that's the assisted mode where there are machine assisted task automations that happen with somewhat lesser input. Still, pretty much the operation is show is run by people having tacit knowledge. It's slightly better, marginally better efficiency, but it's still way off the objective of autonomous enterprise. From there, the maturity moves on to augmented. This is where now there is predicated actions that trigger. It may be not just tasks, but it may be compound actions, handling situations and things like that, so that it starts mimicking the way people do things, where they are thinking and acting together. Actions are based on predicate actions, predefined heuristics, and this is much better in terms of consistency, much less prone to errors. And the nirvana state for us is autonomous IT, where the IT or the brain that is operating the IT is able to learn, adapt to changing environments, changing workloads, changing technologies. It has the ability to reason, think, and act so that situations can be dealt with and not actions, tasks can be performed only. More reliable, lot more sophisticated decision making, not based on rules. A lot of AI, machine learning, context needs to be there, obviously, for this to work. And of course, there is a continuous learning feedback, which is what makes this interesting. And that's really the North Star for us. That's what we are aiming for. Yes, our purpose, we are committed to help enterprises become autonomous IT. How do we do that? So we have a three-pillar approach. We call it unified observability, or sometimes we call it business observability. It is all about learning what is happening, observing what is happening, uh, integrating into the plumbing, which may be monitoring parts of the estate, but bringing the unified view of vertical stack observability, horizontal data flows, transaction observability, as well as experience observability outside in. Then that observability feeds into AI-driven insights. This is where decision making, reasoning, insights, observations, lot of data mining, machine learning, traditional AI, agentic AI, generative AI, all of this kicks in. And finally, we don't stop at just giving recommendations, but we actually try and close the loop by giving prescriptive recommendations with high enough confidence so that the value actually gets accrued and it's just not an advisory system. So these three pillars, they create a virtuous cycle, and that's what we believe will eventually lead to autonomous IT operations. So what does this help us with? There are three simple values that this provides. First is eliminating business disruption that happens due to IT. This everybody likes, every IT operations wants to get this done. Second one is ensuring IT finds issues before business does, so that you don't get a barrage of calls and then you are reacting to it. Third one is, even if the issue happens, self-heal fast enough so that the issues feel more like a blip and there are not a lot of pain minutes associated with the issue. That's really what the three values that we are trying to derive using the three-pillar approach. I'll explain how. So let's take a look at a prevalent IT operations model, right? There is monitoring generates alerts. Alerts go to the level 1 team. Sometimes they are called command center team. They will assess, register, and assign that incident to somebody. From there on, the level 2 technology teams, which are organized in technology silos, pick it up. They try and triage and resolve the ticket. If they can't, they will escalate. It goes to the level 3 teams, who are again organized in similar silos. They will validate if the issue has been resolved at level 2. Otherwise, they themselves will roll up their sleeves and triage and resolve, and so on. There is governance, which is done by operations management team, which sits outside this silos. And then, of course, there is problem management, which is supposed to bring in continuous improvement. What happens is, a lot of activities are happening. All of these are done by a lot of people, divided into teams and silos and layers. As a result, there is a fair bit of disconnect in the way this prevalent IT operation works. So we did a survey for about 300, 600 delegates who have been using AIOps for last 2 years, roughly. And we looked at their responses on what kind of use cases they are trying to leverage in the future, immediately or within the next 12 months. And it kind of brings to the fore the fact that all of these use cases that these practitioners who are responsible for IT operations want to get enabled, they have the liability for it, are all applied use cases. They are taking care of, let's say, event management, which is going to reduce a lot of grief and effort that is spent in dealing with noise. Then incident management, which is going to take out a lot of errors and effort that is going into fixing the incidents reactively day and night, 24/7. Proactive problem management, as you can see, is fairly high on the radar because this is an area which is often deprioritized for some burning issue. And there are always going to be burning issues. Tickets, observability, patch management, these are some of the areas that came out of this survey. In addition to this, there are two more driving forces, which is in some sense fueling us on this journey. The first force actually comes from technology itself. There is a lot of improvement in the general term AI in the last couple of years. The veracity has improved, accessibility has improved, it is much easier, it is a lot more trustable, it's no more random, it's no more toy. Applied use cases can be actually done consistently with it. So there is a lot of adoption happening. So whether it is Gen AI or AI agents, Agentic AI, or the more traditional machine learning, data mining, predictive AI, causal AI, all of it, right? So this entire spectrum.
Rahul, can I ask you, Rahul Kelkar, Silverton Consulting.
Sure.
Can I go back to the prior slide? Can you explain what's the vertical access here?
So in some sense, their focus areas weighted.
So this is not a partition of the incident types. That
No. This is a survey on what use cases
customers are
practitioners, 600 people are seeing right now and want to do it using Agentic AI or AIOps.
So number of respondents or percentage of respondents for answering?
In some sense.
And the expectation here is that 12 months later with AI agents, this is how it's going to look?
Okay, so I will answer it slightly differently. This is where they feel confident. In 12 months, if I rerun the survey, they might give a different set of use cases as what they will be aiming for.
But this is their expectations today.
As of now, yes.
Yeah.
Okay, so continuing. So I talked about push from technology. As a result, it is almost mandatory to have AI driving anything and everything that anybody does. And it's almost, you get disqualified if you don't have AI in anything that you are trying to do afresh. So it's a tremendous push and we like it. We are able to leverage, validate it tremendously. The second driving force that we see is pull from businesses. And this pool is actually very strong. And when I say business, it is the enterprise ITs of the world. Most modern applications that are getting built and deployed are cloud native. So they run on microservices, containers, and things like that. As a result, the type of management observability required on such architectures and such type of applications is very different. All of these applications inherently use a lot of AI as part of the business application stack because they are using AI. That's on the technology part. On the operations part, there is this traditional pyramid you see, right? There is a large level 1 command center service desk team, smaller level 2 teams, further smaller L3 teams, and
Now, Rahul, we've seen various versions of MIT's report that says 95% of AI proof of concepts fail. So you're seeing that the businesses are actually implementing AI adoption in their container workloads and things of that nature. I mean, it seems like it's contrary to what we're seeing.
okay. So I wouldn't say that all the workloads have AI, but the situation 3 years back was, okay,
Not-
AI is in the lab
Yeah.
and there is nothing in production. But that's no more the truth. There are AI workloads in production.
Coming out. Okay.
That's what I mean. Yeah. Okay. So going back to the pyramid, a smaller number of architects, very few. That pyramid is definitely getting disrupted to a more nimble SRE kind of model. People have different ways of calling it, but that's really a smaller number of people who have multiple talents, multiple skills, if you will, and they have the end-to-end responsibility of dealing with something happening, continuous improvement at the same time to improve the overall efficacy, efficiency, and experience outside in. That's the transformation we see, and that is another important pull that we have. That's the driving force behind what we have.
So you're saying that architects are the least most likely to recommend Agentic AI? Is that what you're saying?
No, that's not what I'm saying. If you take a more traditional IT operations setup, there are very few architects in that mix.
Oh, okay.
The largest number of people are level 2 engineers who are very siloed. They just have one technology view, and whereas the newer model is not like that. There are no silos. The people have a comprehensive view. There might be a view of, okay, I'm responsible for these set of applications, but there is no further division on, oh, I will only look at database. That's what I meant. And as a result, there is a lot more emphasis being given on experience and not SLAs, because SLAs is a nice way of governing distributed siloed teams. That you set SLA at every level, level 1 SLA, level 2 SLA, level 3 response time SLA and resolution SLA. And then the whole game becomes reporting governance on are the SLAs green or red and things like that. So there is this famous thing called watermelon effect, where all SLAs are green, but if you look inside, it is all red. So that's what happens typically, and fairly common occurrence. Instead of that, now there are few people, I mean, there are like 50 SREs, and thou shall be responsible for everything that happens. So there is no more watermelon there. They will be red in some sense. So what we foresee, and we see a tremendous transition happening to this model. It's not like overnight it is changing to this model. There is still going to be monitoring tools. They will still raise alerts. Now, instead of these alerts going to level 1 team, the first right of refusal goes to an AI agent that needs to deal with that alert. So the AI agent is now going to look at that alert, assess it, filter, suppress, aggregate, validate, right assign it if it needs to be resolved, and then it will register an incident. Once it registers, another AI agent will pick it up, try and see if the agent can do a root cause analysis, automatic healing of that issue. If not possible, because there are always going to be exceptional situations, new situations, which have not been encountered in the past that AI is unaware of, then it needs to be escalated. And this is where the smaller, nimbler SRE teams come into picture. The escalation point for AI agents is going to be the SRE team, much smaller in size. Of course, there is going to be operations management. It's required to govern the whole setup. What is happening in this process is same set of activities that are being done are now re-aggregated into a fewer roles. There is only going to be an SRE team and the operations management team. But then the scale is going to come through AI agents. That's really the model. Lot of activities in the earlier picture, all of those are still required to be done. But they are done by a fewer set of people performing more activities augmented by AI agents, the AI agents are going to provide the scale. That's really the shift in the model that we foresee, and we see a lot of our customers on this journey. I wouldn't say that they are there, that will be foolish of me. So finally, I mean, what are we trying to transform, right? If you take a very simplistic view of enterprise IT setup at the top, right? It starts with a infrastructure, cloud, a mix of that at the bottom. Then you have containers sometimes, then you have other platforms, databases and other things. You have end user devices. Then you start getting into the traditionally called application stacks, where you have batch streams that are running batch processes. And then you get these applications which are bespoke. It could be COTS applications like SAP. And finally, you have the business value streams. This is where the business function executes across multiple applications. Transactions are flowing to get something done, whether it is order to cash, procure to pay. All those transactions are flowing across a multitude of these applications. And that's really the stack we are trying to manage when I say enterprise IT. Of course, there is security, which cuts through all of these layers. Now, what does ignio do? What does ignio bring to the table, right? We talked about 3 values. So the first value, ensure that IT finds the issues before business does. It is enabled by 2 critical modules, functions, capabilities of ignio, if you will. First one is observe, the second one is analyze. So what does observe mean? Of course, every enterprise has a multitude of monitoring tools. There is no point in bringing yet another. But we also have seen with 250 customers and 10 years of experience that there are always gaps in the monitoring. There is always scope for improving the quality and precision of the monitoring. That is where this metrics, events, logs, traces kind of thing, we augment the existing plumbing. There is always scope for hierarchical business specific health checks. These are not single point in time checks that you are not checking CPU, but you are checking a larger business level outcome, which may be dependent on a bunch of things going together hierarchically. Then there is business health, because the health check is not just restricted to business application, but it needs to get into business functions. That is this, let's say I have a merchandising business function in my retail operations. Is that business function healthy? That question can be answered only when all the applications used by teams which are delivering that business functions are healthy. And then that question can be answered only if all the vertical stacks are healthy. And that's how the vertical stack kind of becomes green. But that's not the end of it. While all the applications may be fine, there are still going to be issues in horizontal business transactions that actually flow from application to application. And there could be various reasons for it: data issues, network issues, many other issues, which vertical stack still may be green. Now, from this observability, there is a need to now leverage a lot of machine learning and AI to analyze, right? So there is this event management where there is a need to autonomously remove whatever 80-90% noise that is there in every anomaly that gets detected and raised as an alert, right? Otherwise, the teams are going to spend, even if they spend 10 minutes on every alarm or alert, you get 10,000 such alarms in a day, they are going to be busy forever. So you don't want the noise to reach those teams as much as possible. Once that happens, and let's say you remove 80% noise and 20% incidents remain, again, it's a lot of work, because every time recurring issues keep on happening, there needs to be a way to automatically triage, perform root cause analysis and figure it out. There are scenarios where the IT metrics and KPIs need to be correlated to business KPIs and metrics. For example, in a retail store, footfall is an important metric that the business measures. And there is a direct correlation between if some POS terminal on lane 3 is not working, footfall goes down. And so there is a necessity to correlate that context of business issues with IT issues so that the people have the sense of urgency to do it. Last but not the least, change. That is almost single-handedly the largest culprit for all issues that happen in IT. Things are stable when there is no change. Suddenly you introduce change every day, every week, every month, something breaks because of the side effects. From there, second value, once it is observed, analyzed, then it needs to be self-healed fast enough so that it feels like a blip. You don't have a lot of pain minutes associated for the business, whether it is self-healing incidents, auto-fulfilling requests, change request, service request, or performing other life cycle activities like certificate management, patching, and many other things that happen in a typical IT operational setup. Last but not the least is eliminating business disruption that happened due to IT. This is, like I said, an area that is often deprioritized because some priority one issue, some priority two issue is permanently.
Where does ignio, what is ignio here? Is that whole bottom section
Yes,
ignio's
that is what I'm saying.
capabilities
Yeah.
that you're bringing to the play?
Exactly. It is trying to manage the stack at the top. And I'll get into more details of how it exactly does that on this slide only. So the improve piece comes from ability to systematically eliminate tickets. We call it ticketless. The idea is not logging tickets, but idea is systematically not generating tickets, putting fixes, elimination fixes so that you don't get the issues in first place. Capacity has been a perpetual issue for last decades. Cloud cost is becoming another dimension. Apart from response, availability, all of that, cost is becoming critical because most business cases are not met when it comes to moving to a multi-hybrid cloud kind of setup. That's the improve piece. All of these set of features are running on what we call as Ignio Enterprise Blueprint. It is nothing but you can call it a digital twin of your enterprise IT. It captures both structural aspects as well as behavioral aspects of the IT. The modern name for it in the industry is knowledge graph. All of this, of course, there are a bunch of AI agents, and I'll go through that in the subsequent slides. These AI agents are purposive. They are augmenting day in the life of specific people. I talked about a lot of roles there on the earlier slides. These agents are doing life cycle activities, whether it is event management, incident resolution, problem management, business SLA predictions, cost optimization, and they are collaborating and augmenting with some of those personas on earlier slide. Of course, the ways to collaborate are through conversational essays, notifications, dashboards. Many of these modern SRE kind of personas want to be hands-on. So they want the ability to extend existing functionality on a continuous basis. So that's why we have Ignio Studio, which allows them to sort of extend functionality.
So in this case, are you using standard LLMs to drive these agent workflows, or are you doing some special services, special models that are associated with enterprise ops, or
So
what?
we have a three-pillar approach there. Somehow we like three pillars. The first pillar is what we call as logical reasoning, which is based on machine learning, traditional AI models, a lot more deterministic. The second pillar is analogical reasoning, which is dependent on generative models, which work on a general book of knowledge. Third pillar is assisted reasoning, which is where we bring in the experts that have the tacit knowledge, so that the generative analogies that are coming out of general book of knowledge can be specialized, personalized for that specific enterprise situation. So we use this, what we call as full spectrum or composite AI. There are other names for it. And that's what really it is. It is not one answer that we are using this, open this or that. And I'll get into next slide into details. I'll give some examples.
Can I? So let me frame what I've heard so far. Scott Robon, Solutional. Interesting architecture, makes sense. I feel like you've made claims that I can't tell if you mean they are present state or are future. I think the best way would be to see what you're doing, and with some real customer examples that demonstrate autonomous agentic behavior.
Absolutely.
I don't mean you have to fast forward through everything, but I think that would be the best way to answer, I think, some of the questions we have.
Perfect. So we have organized this session in three parts. I will go through the product, then I'll go through demos for 25 minutes. All of the agents I will demonstrate. And then Rajiv will cover the customer scenarios.
Okay. We had
That's
5,
okay?
right? I remember 5 customer from
Yes.
last night. Okay.
Okay. So moving on, let's skip this. So we have, like I said, right, we have been around for 10 years, and it's a field that is changing quite rapidly in the last 2-3 years because of whether you call it Gen AI or any other thing. Traditionally, AIOps, the way the industry has defined, and it is also evolved over a period of time. It is all about contextualization, correlation, anomaly detection, prediction, if possible. We as Digitate have always looked at AIOps as not just these 3 pillars, but we have always looked at it in conjunction with closed loop automation. The point of detecting anomalies, point of predicting and prescribing fixes needs to take the last step, last mile, and apply automation and resolve those issues. That has always been our definition. From there, we have matured into leveraging Gen AI to bring in efficiencies, right? Previous releases, whether it is chatbots or code accelerators here and there, so that the overall value journey for a customer becomes accelerated. With the latest release that we have out in the market, that is the Agentic AI release. So to answer your question, I'm talking about what is out there generally available and not coming out in the future.
When does your timeline start? So what year would you put on your first AIOps bubble?
So we have, so our journey 2015,
Okay.
we called ourselves cognitive automation. So the idea was, I mean, there always has been automation, runbook automation, whatever you want to call it. We wanted to make it a little bit cognitive so that it is able to sense and understand in what scenario, what automation to use. And that was really the play for first couple of years. At that time, there was no category called AIOps. Nothing was defined. As we started doing that, deploying it across customers, this category emerged, and this was great because we were naturally born into that category. The category was saying almost 80% of what we were doing. We were saying 20% additional. And that's where we started calling ourselves AIOps for IT operations with the 3-pillar story.
Okay.
And very recently, we have now that scaled it into this modern stack that I showed, modern IT operations way of operating, Agentic AI platform for IT operations. So that's really the 3, if you will, 3 phases of evolution.
Okay.
So this is the slide. So the AI, Composite AI, right? I talked about logical reasoning. This logical reasoning is based on models. So it is a lot more deterministic for a given model. It leverages a lot of enterprise blueprint, which of course needs to be populated by doing a lot of data mining, machine learning. It captures structure, dependencies, behavior in terms of workloads and monitoring data, event data, incident data. Then models kicks in. There is, of course, the domain IT model that we bring into the table. Combined with the enterprise blueprint, which is situational model, there is model-based reasoning, case-based reasoning. A lot of that is enabled by machine learning and traditional causal and predictive AI. Closed loop automation. Of course, this adapts to changes and it frees up people's time in the prevalent IT operations model. That's really the first pillar. The second pillar is, now the challenge with this is assuming that sufficient information is available for the machine learning to kick in and take decisions. In many scenarios, dependencies are partially known, monitoring data is tersely populated, there are gaps in that data. As a result, one has to make assumptions about both the dependencies as well as the behavioral model in a typical IT setup. And that's where it starts becoming, time to value starts becoming longer, because then you spend time in populating that blueprint so that the answers to the model are more trustable, or you go on, right? So that is where we started bringing in this, what we call as analogical reasoning. It augments this existing knowledge of enterprise blueprint and the domain models with analogical reasoning, right? This is the general book of knowledge that I was talking about. The combination of this works great because it solves this problem of I don't have complete information in all parts of my IT operational setup. Wherever you don't have to wait for populating that, all of that. So you start getting value right off the bat. And then the advantage of using analogical reasoning is there is this inherent ability to learn, adapt, and generalize, so that you are able to now apply some of this learning into situation which may not be exactly same when it happens subsequently. The last pillar is assisted reasoning. This is very important because analogical reasoning is going to get you generic advice, which is general book of knowledge, right? It needs to be contextualized and specialized for tacit understanding of that specific understanding. So there is going to be collaboration always between analogical reasoning and assisted reasoning, and that is where we see that the experts come into picture and overall effectiveness of the system becomes very, very sharp, if that's the term. Advantages are great. I mean, you don't have to spend a lot of time in populating context before you start delivering value. Lower variance, because now this is an approach which is augmenting different personas that are playing that role. As a result, there are going to be experts who are super smart, right? There's no issue with that. But there are going to be people who have just joined a couple of years or 3 years sooner or even lesser than that. They are not as effective in dealing with situations. But this augmented approach kind of augments everybody. So the overall effectiveness of everybody is going to go up. As a result, the variance will drop between the elite versus the average. Of course, this is a great way of dealing with complex unknown scenarios, because in the first column, if there is an unknown scenario, I mean, there is nothing that model will do. But this is a systematic way of dealing with that, so that next time a similar situation happens, the whole composite AI is able to deal with it. This is really the crux of what we are doing. And let me now explain this a little bit more in details. Sorry. Let's take this example of event and incident management. I talked about enterprise blueprint that needs to be populated, whether it is the application stack. I mean, this application runs on this server and it is connected to this database, and I mean, there are a bunch of dependencies like that. In addition to that, there is a behavioral aspect of it, that monitoring data is that there at each level, and all of that blueprint needs to be populated using a multitude of data mining and other techniques. You bring in this information that is available in a lot of enterprise IT data sources, whether it is monitoring tools, ticketing system, Excel sheets that people maintain when they are managing their own databases or servers. All of that we bring together. Of course, there are conflicts and we figure that out. Now, what do we do with it? On that, we run a bunch of machine learning algorithms to deduce expected normal behavior. So this is going to tell us this server, this application is going to behave at this level between 10 and 12 on a Monday morning. And the subsequent servers on which this is running, the utilizations levels are going to be 74% to 79%, right? And this is what is derived using a lot of machine learning from the data. There is graph data dependencies, there is time series data, which is all this metric information. There are few more things that happen as part of logical reasoning, right? Using the same information, we also mine a lot of filtering rules. These are rules or association. We do association rule mining on that data to figure out, are there scenarios where people are just not acting on certain types of alerts, having certain characteristics. And these are great candidates for filtering, because anyway, nobody is going to act on it. Then similarly, we figure out co-occurrences of alerts that are happening together, either one leading to another, or they are co-occurring together as bunch of alerts. We also figure out dynamic thresholds. I talked about on a Tuesday morning between 10 and 12, this is the level of utilization expected based on significant persistent changes that have been observed recently. Classic machine learning. And this is all done through the logical models. This is where now assisted learning comes into picture. There are going to be experts who come into play. They look at the suggestions for filtering rules. They will look at the evidence provided. They will confirm those rules. They look at the co-occurrences. They will promote those co-occurrences as correlations when it comes to alerts. And they will look at the dynamic thresholds that are suggested, and they will confirm those thresholds. As a result, now the machine is now more tuned for filtering irrelevant alerts. Again, logical reasoning. suppressing redundant alerts based on the correlation signatures, and suppressing noise based on the dynamic thresholds. Now, what happens is, as part of this exercise, there is always going to be some parts of the enterprise blueprint that are not fairly populated currently. So naturally, that shows up as errors in this process. So naturally, a side effect is suggestions for blueprint enhancement so that the overall effectiveness goes up. These enhancements again are done by assisted reasoning to enhance the blueprint through conversational interfaces. Now, let's say this happens, and over a period of 2-3 months, this becomes more and more efficient. 70, 80, 85% of the noise is now reduced from your alerting system. Now, all the incidents remain 15%. They need to be now dealt with, right? So there is automated root cause analysis. If the root cause analysis using model-based reasoning is confident enough and there is high enough support, then it goes into auto resolutions because the prescription is good enough with high enough confidence. In scenarios where there is not high enough confidence or not sufficient support data, then again experts come in, they confirm the root causes identified, the fixes prescribed, and then the machine keeps on learning from it, right? All of this can be done through conversations. Now, in scenarios where none of this is working, the machine simply doesn't understand what to do with this scenario because it has not happened before or not sufficient information is available of dependencies around that. This is where now analogical reasoning comes into picture by now suggesting summary, providing historic context, debugging context, automatically suggesting fixes through general book of knowledge. And these fixes now need to be assisted again with tacit because there is this risk of something being said which is not right. Once that confirms, then that fix gets operationalized the next time. So the idea here is, it has always been composite AI for us. We are not dependent on a specific LLM or anything like that. We always try and do everything logically first, if not analogically, and then assisted. That's really the crux of the basic idea behind Ignio. Let me take an example. Let's say I am an SRE person and I come in the morning. And naturally, I will ask this question that, is there anything that needs my attention? And now the perception part of the agentic AI kicks in. It will monitor the incidents that have been happening in the last few hours. It knows who I am, my context, what is my responsibility. It is now going to infer, give it to the reasoning agent, which is going to now assess impact of each of those incidents, prioritize those incidents, and then present me a list. So now, as an SRE person, otherwise I would have to shoulder tap 3-4 people, look at some Excel sheets, dashboards, and figure this out. So I can simply ask this. Okay, great. Then I pick one of those and say that, can you help me diagnose this issue? Now, perception agent is going to kick in. It is going to find out, let's say this application is slow. That's the incident. It is going to find out, okay, what are the influencers in that hierarchy of that application? Is it running on a Linux server, Oracle database? What is the app server? Is it running on a virtual machine? Is it on cloud? Is it on-premise? All of that, right? This is the dependency hierarchy. Then it is going to infer the expected normal behavior. I talked about machine learning defining the envelope of workloads. Then it is going to perform a bunch of real-time health checks. It's almost like a blood test, if you will, right? You perform a blood test, you compare results of various metrics of that blood against ranges, right? The range is defined by the expected normal behavior in this case, which is dynamic in nature. And then whatever is out of that range actually is anomaly. So the diagnosis becomes simple. Okay, I checked at 14 parameters across 3 dependencies, and 2 of them are out of the expected normal range. And that's the result I get, that okay, maybe those are the probable causes. So now I ask the agent that, okay, give me a historic context of this. Have similar things been seen in the past, and what happened when this happened? So then again, perception agent kicks in. It tries to identify a cohort of incidents that are similar along multiple dimensions. It then tries to infer common causes that happened during that incident, common fixes that were applied, it worked, didn't work, whatever it is. If not possible, then it will go back to analogical reasoning, reach out to an LLM, bring that in, bring human in the loop, and that's how it continues, right? Okay, I'm happy with the fix that has been suggested, analysis that has been done. Go ahead and apply this fix and tell me if it fixes the issue. The agent is going to then check for safety and conformance of that fix, validate that fix in some sense, apply that fix. It may be one fix, it may be multiple fixes at multiple layers in that hierarchy. And of course, it is going to learn from this investigation. And this is exactly how, the way I explained earlier, the three logical reasoning, analogical reasoning, assisted, this is how it is going to work together. I will, of course, show a live demo subsequently. Now, I talked about a lot of personas that are playing different roles. We want them to be only SRE teams, or rather enterprise IT wants them to be only SRE teams which are smaller and nimbler, and many enterprises are there. But otherwise, it is going to be a mix of traditional operations teams, some SRE, there is the CIO, IT management layers. All of these people actually perform a lot of day in a life jobs, right? For example, SRE or operations team, they will monitor, they will investigate, they will resolve, they will validate, they will improve, they will govern. Whereas the IT management or CIO kind of personas, they are largely going to focus on improvement, transformation, and governance, right? Now, I talked about these agents, and I just used 5 agents as example, who are going to augment the day in the life of many of these personas. You can imagine from the example given, most augmentation is going to start from left-hand side. So the agents are going to first do a lot of augmentation on monitoring, investigation, resolution. And job of people will slowly remain as validation, improvement, and governance. And slowly the agents will also start suggesting improvement opportunities. As a result, the people are going to only handle exceptions eventually. That's really the dream, but we believe strongly that that's where we are going. As part of this autonomous enterprise, yeah.
Sorry, Carl Fugate, can you go back with just 1 second? So I'm just curious, and we can talk about it later if it makes sense. So from the monitor and investigate kind of phase, especially monitoring, there's most teams have tremendous amounts of logs, which are very expensive
Yes.
to move.
Yes.
But I would imagine your tool is going to need access to those in order to provide value. How do we go about that?
So, yeah, great question. So the more the merrier. That's the simple answer, right? So let's say if you have a hierarchy of an application, there is going to be monitoring data, some metrics at application level, application server level, database level, OS operating system level, network, storage. And those are relatively easier to get because it's not that expensive to get that much data. The challenge there is what metrics are getting monitored. And that's where I talked about Ignio coming in and augmenting this thing, because unless the model is not sufficient to derive conclusions and reason about it, it is going to not produce good results. Having logs is going to be great, but you don't really need entire log. That is our experience. All you need is anomalies from the logs, which is going to be a lot lesser than transmitting terabytes of data. So our approach is only deal with log anomalies and not complete log. So if you already have log at some place, we have ability to just extract anomalies and deal with that.
Do you need just kind of access to raw metrics, or do you have plugins to support other tools that you might already have?
Yes. So if we always run into yet another tool, but more or less the standard 30-40 tools that are out there, we cover out-of-box adapters for those. So that's not an issue. But like I said, there is always yet another tool that is used by somebody. So that in that case, we build that adapter.
Okay.
Many a times the tools are supremely customized. So our adapter doesn't work out of box, so we'll have to tweak it. Okay, going back to the enterprise autonomous suite. Of course, AIOps is our main offering because it covers infrastructure, cloud, application stacks. But there are specific nuances related to COTS applications like SAP. SAP by itself is an interesting, I don't know whether to call it animal, but that's the word. And it has these ECC, S4 HANA, and Suite on HANA. I mean, there are those variations that are there. So we have a specific offering where it is trained on specific SAP architectures and models because it's a different game. Then we have a specific module similarly trained for batch schedulers, right? So lots of enterprises run literally tens of thousands, if not hundreds of thousands of batch jobs. And they just keep on running, they keep on firefighting. So we have a module which sits on top of schedulers and it specifically deals with that. Then we of course have a specific module for digital workspace, endpoints. Procurement is another area, it goes into the business realm, but we have a module there, and software assurance for release validation. So those are really the, if you will, packaged products on this platform that we take to the market.